Hello everyone. In this video, I'll go through the main features of iRotor Balancer app. It is an iPad app connecting to Motionics 2-channel wired Rotor Balancing Kit for single plane and two plane balancing. First, let's look at the single plane balancing with full-round method. It only requires one channel acceleration input. By placing trial weight at different locations on the rotor and taking measurements from accelerometer, proper correction weight and angle can be calculated to balance the rotor. The top section of the app page is for balancing process. User can enter vibration amplitude directly in the text field. Or press the Get button to capture reading from accelerometer. Trial weight can also be directly entered. Or use the estimation tool to calculate a proper trial weight value. Get vibration readings at different locations one by one and press correction weight button to compute correction weight. The camera lens button opens the camera view with overlaid red target icon on a circle. Point the camera at your rotor and align rotor edge with the circle. The position of the red target icon is where you should place the correction weight on the rotor. This tool is helpful for quickly finding the correction weight location if there is no angle markings on the rotor. If adding a weight is not a viable option and removing material is needed instead, user can use the removal weight calculator. When it's loaded, it automatically calculates removal weight and hole location based on correction weight information. It calculates drill length if drill diameter is known, or the other way around. Down the bottom is a selector to select the rotor material, including copper, lead, steel, stainless steel, and other common metals. The bottom section of the app page shows a real-time signal viewer. It continuously updates vibration signal in time waveform or FFT spectrum. Acceleration signal from the accelerometer is used directly for analysis or integrated to velocity. You can use 2 fingers pinch to a specific frequency range. There is a peak marker in FFT spectrum. When it's set to auto mode, the app automatically detects high peak and places a marker there. When it's set to manual mode, marker follows finger touch on the signal viewer and adjusts its position. Vibration information including peak amplitude, 1x frequency, and RMS value are displayed on the top right corner of the viewer. Data acquisition can be paused by pressing the pause button on the viewer. Other tools available include a polar plot. It shows trial and correction weight positions and vibrations on the polar plot. It's a good tool for visualization and verification. There is a permissible residual imbalance calculator converted from ISO 1940 chart. User can enter rotor speed, mass, number of balancing planes, and select a proper balancing grade to calculate permissible residual imbalance value, and quickly assess balancing quality. Another helpful tool is weight angular split calculator. When the calculated correction weight position is not accessible on the rotor, user can use this calculator to split the weight and distribute them to two weights at other available locations. Once balancing is complete, a test report can be generated. On top of the report, user can enter general information such as report title, date and time, staff name, machine and plant. Company logo can be added to the report from camera or photo library. Similarly, machine images can be attached. Middle part of the report shows balancing parameters and vibration before and after balancing, including an option to attach vibration spectra to the report. The bottom section has several fields for adding notes, signature, and map. After editing, you can press View Report button to read generated PDF report. There are options to share the report via email, wirelessly print, or save it in the local report manager. Next, let's move to single plane using vector method. Unlike four-run method, this method requires two channel input, one for vibration from accelerometer, the other for phase from laser tachometer. The app simultaneously collects signals from both channels and computes vibration amplitude and phase, as can be seen from the signal viewer. 1x phase and tach RPM are also displayed. I don't have the hardware connected, so the value is 0. With the phase information, balancing can be completed with two rounds. In the first round, user presses the first get button to measure original vibration and phase. After trial weight is added, user presses the second get button to measure vibration with trial weight. Then correction weight and position can be determined. After removing the trial weight and adding the correction weight, user can press the set get button to capture vibration after correction to verify the result. Train weight may be added if further refinery is needed. Similar to for-run method, a PDF report can be generated and saved after the test. iRotor Balancer also supports two-plane balancing. For inbound case, rounds are required. In the first round, original vibration amplitude and phases on the two balancing planes are measured separately. In the second round, a trial weight is added to plane 1 and the user captures vibration on the two planes. In the third round, vibrations are recorded as the trial weight is moved to plane 2. Finally, correction weights are calculated and the fourth round can be taken to verify the balancing result. Train weight may be added if further refinery is needed. A PDF report can be generated and saved afterwards. For overhang balancing, two phases balancing are conducted. First phase is to find the static correction weight on the inner plane and accelerometer is placed on the inner bearing support. Similar to single plane balancing with two channels, user captures original vibration, adds a trial weight to measure vibration with trial weight, and calculate the correction weight on inner plane. Next, for the second phase, to find couple correction weight, accelerometer is moved to the outer bearing support to capture original vibration. Trial weights with the same value but 180 degrees position shift are placed on the two planes. Vibration with trial weight is taken. And finally, couple correction weight can be calculated and added to the two planes. A PDF report can be generated and saved afterward. Next, we will revisit all the test reports we saved from the report manager. It is organized in the plant, machine, report structure. User can easily locate a specific test report. Once a report is selected, a pin drops on the map to show where the balancing work was conducted, and the PDF test report displays in the report view. Use the full screen button to expand the report to full page. Sharing the report via email and wireless print are also available here. To delete a plant or a machine or a report, simply slide the selector row to the left. Let's go back and check the setting options in the app. Here you can select to use metric or imperial unit, CPM or Hertz for frequency unit. Default vibration measurement parameter can be set to velocity or acceleration or displacement. There are also some spectrum settings including FFT resolution and line thickness. Additionally, you can choose dark or white theme for the app, background and text color will adjust accordingly. Finally, overall vibration RMS or 1x peak can be selected as calibration reference. iRotor Balancer has a separate page for easy calibration. If you have 1G 159Hz shaker, you can connect it to the accelerometer as illustrated and simply tap a button to calibrate the system. If you don't have a shaker, our hardware device ships with its calibration number and you can enter it here. Here is a separate page to check two-channel inputs. The signal viewer is similar to the one available in balancing pages, with additional options including selecting input channel. You can select channel 1, channel 2, or both channels. Changing numbers or points for averaging. Quickly selecting frequency range. Turning on and off two channels phase difference. Changing line thickness. And adjusting frequency unit. If you need any help, there is a help page in the app to explain general buttons and features, as well as instructions for different balancing methods. For further information, please visit Motionics website www.motionics.com. Thanks for watching.